เสียงปรบมือต้อนรับด้วยครับ
What I got? Let me connect.
เดี๋ยวเรามาแจ้งอีกทีนะครับเดี๋ยวแจ้งช่วงประเด็น
So, my name is Guy. Nice to meet you all. I'm very happy to be here. Great honor for me. I'm from Israel. I'm leading the user group, just like yours, in Israel. We have a meetup as well. It's really great. It's happening for about 20 years. I know that here is just the fourth meetup, right?
Yeah.
Okay. So well done. 4 meetings, so many people. It's really great. Really great. Well done. Okay, so I'm a data platform MVP. I've been working with SQL Server for the past 20 years, more or less. Currently working at Madeira Data Solutions. We work with many, many clients on all kinds of projects, administration issues, development, BI. So I see a lot of projects, a lot of environments, a lot of things. And one of the things that I see a lot with performance issues is wrong handling of parameters in SQL Server. See all kinds of examples, all kinds of cases where developers don't use parameters the right way in SQL Server. And from my experience, this is one of the most common cases for performance issues in SQL Server. So this is why I chose this presentation. I want to show you some use cases, some scenarios for using parameters and what it can cause in terms of performance in SQL Server and what we can do about it. Okay? I hope my English is good enough. I will try to speak slow enough, okay? Let me know if you don't follow me. So, let's begin with a story. Okay? It happens to me a lot. I get a phone call from a client, and the client tells me we have a performance problem. We have a stored procedure that used to run for just, I don't know, 50 milliseconds or so. And at some point in time, starting, let's say, 2 a.m., it's always at night, okay? At 2 a.m. at night, this stored procedure started to run 6 seconds each time. Instead of 50 milliseconds, 6 seconds. And it's consistent. It's not just one time. At some point in time, it started to run for 6 seconds each time. And this is a real problem. You have to help us now. Okay? So at this point, I say, okay, if at some point in time it started to run in a different way, something changed, right? So I asked the client, what happened? What happened at 2 a.m.? Did you restart the server? No. Did you change any code? Did you upload a version? No. Did you add an index, remove an index? Maybe no. Maybe you uploaded a lot of data. Maybe there was a lot of traffic suddenly. No, nothing changed, nothing happened. It's first. Okay, so let's try and see what's going on. Okay, I will show you during this presentation what happened, and I'll show that these things happen in your environment as well, because I see them all the time. Okay, so I'm going to talk about parameters, parameterization in SQL Server, what it means, why is it so important, why we need to understand how it works, when does working with parameters becomes problematic, what is the problem, and of course, what we can do about it, how can we deal with it, okay, to make it better. So this is the purpose of this presentation. When I talk about parameters, I talk about this, okay? This number here. It can be a number, it can be a different number, it can be a parameter, okay? And we can have all kinds of predicates, of course. In this case, we have an equality predicate. We can also have an inequality or between or something else. But I talk about those values over there. For the sake of this presentation, I'm using a very simple demo. I call it the customers by country case studies, and it looks like this. This is the query I'm going to use in most of the presentation. Okay, so it's very simple. I have a customers table, marketing customers table, and within this table I have a country column, and I want to retrieve all the customers from a specific country. In this case, from Israel, where I come from. IL stands from Israel. Okay, very simple. Let me show you how it looks like. This is Okay. So it's like mine. So here it is. This is the query. Let me add the execution plan and run it. So in this case, in Israel, we have 55 customers currently coming from the query. And if we look at the execution plan, maybe take that aside. Thank you. So we have 55 Israeli customers. In the execution plan, we can see that we have an index SIG, because of course we have a non-clustered index on the country column. We have an index SIG, and then for each customer, we have a key lookup to get the rest of the columns. Yeah, that as well. To get the rest of the columns from the clustered index, from the table. Okay, very simple query, very simple execution plan. So far, so good. Another thing I want to talk about, because it's going to be relevant later, if we look here, we can see that the estimated number of rows is 55, the actual number of rows is 55. So the optimizer did a very good job estimating how many Israeli customers we have. Okay? It knew we have 55, it was right, great. So far, so good. Let's move on. Let's talk about plan cache. In SQL Server, we have the plan cache. The plan cache is a memory area in SQL Server where SQL Server holds execution plans. Every time we send a query to SQL Server has to compile and generate a plan for that query, and it puts that plan into the cache in order to reuse it again and again, not having to compile again and again. Okay? So this is a good thing, and this is how it works. Whenever we send a query to SQL Server, it first needs to check whether this query plan is already in cache. Maybe it's there and we can reuse it. If it's in cache, it's not good enough. It also needs to check that the plan is already valid. Maybe it's invalid. Now a plan in cache might become invalid for all kinds of reasons. Maybe statistics were just updated. We have a new version of statistics, so we need to recompile the plan, so it's currently not valid. Maybe something changed to the schema. If someone added an index or added a column, maybe removed an index, any change to the underlying schema will make all the relevant queries not valid. Okay, so the next time we need to execute the same query, we will see that it's not valid, we will have to recompile it and generate a new plan. Okay? So only if we find in the plan cache the execution plan for this query and it's valid, we can reuse it right away. Otherwise, we need to compile a new plan. Okay? Let's see a demo about plan cache. So I'm going to create a view so that it will be convenient for me. This view is going to query the system exec cache plans, DMV, which gives us all the execution plans currently in the plan cache. Okay? By the way, I didn't say so, but you will have access to all the materials here. I already sent it, okay? So you can download the presentation, the scripts, the application, everything. I have lots of information in here, so you'll get everything. So this view will give us all the execution plans currently in cache, and by cross-applying to these two functions, I will get the plan itself and also the text of the plan in cache, the statement, okay, the batch. And I also join to system exec query stats just to get the last execution time, because I want to order by the last execution time so I see it in the right order. So now I will create this view. And let's see what's in it. Okay, so currently on my laptop, this is what we have in the plan cache. Okay, we have all kinds of execution plans. We can see the query text, we can see the plan itself. If I click on some of those, I can see the query plan itself. We can also see the execution count of each one. The purpose of the plan cache is to be able to reuse plans. So I would like to see here high numbers. I want to see queries with lots of reuse, lots of execution counts. This would be a good use of the plan cache. If I see this, lots of queries with only one, this means something is wrong. Of course, this is my laptop. It's not a production environment, so it's not a good example for that. We can also see the object type. In this case, all of these are procedures, stop procedure. So we have an execution plan of a stop procedure. We also can see here some ad hoc plans And ad-hoc plans means a query that I send from the application. It's not a procedure, I send a query, it's an ad hoc. We also can see here a prepared plan. It's not a very good choice of terminology, prepared plan, but a prepared plan actually means a parameterized plan. A query with parameters. Okay, we'll see that later. So when I see prepared, I know that there are parameters involved. We see the size, we see the last execution time. Let's empty the procedure cache, the plan cache. Okay, this statement, dbcc free pro cache, empties the plan cache. Now, of course, don't do this in production. It's very dangerous. Okay? And let's look at the view again. So now it's empty. My plan cache is currently empty. Now, let me run the test query again. Give me the Israeli customers. And let's look at the plan cache. What I'm doing now, I'm using my view, and I filter according to the text. I want to look for only the text that includes customers, so I get only my query. Okay, and here it is. This is the query text, this is the plan. Execution count 1. It's an ad hoc query, it's not a stop procedure. It doesn't have parameters, right? And I'm going to run the same query again. I expect to get a reuse from the plan cache. I don't want another compile. Let's check again the plan cache. And yes, we get a reuse. Great. SQL Server recognized that it's the same query. We have a valid plan in cache. So far, so good. Let's do it a third time. Same query. And check the plan cache again. Oops. We have a separate plan. For some reason, now we have a separate compile, a separate plan. Not so good. The reason is, I lied to you. It's not exactly the same query. I added here a space, a single space. Okay? Just to show you that it takes the text of the query, it calculates the hash value of the text, and it looks for that hash value in the plan. So any change in the text, even if it's a space or a tab or enter or whatever, if the text is not identical, it's a different hash value, it's a different plan. Okay? Now, of course, in reality, we don't just add spaces. But what we can do is use different values here. For example, I want the French customers. Okay, so again, this is a separate text, a different hash values, and therefore we get another compilation. So for every country we are going to use this query, we're going to get another compilation. So we'll have lots of plans in cache. Of course, countries, it's not such a big deal. We don't have so many countries. But think about transactions table, for example. And if we have a query on the transaction ID, we might have billions of transactions. And if we have a query with transaction ID equals some number, and it's not a parameter like here, then potentially we can have billions of compilations and billions of plans in the plan cache. Okay? So you have lots of CPU overhead and memory overhead, and this is really, really bad for performance. Okay? So it's not a good thing not to use parameters this way. All right. Let's go back here. So Paul Simon says there are 50 ways to leave your lover. Okay? It's a great song by Paul Simon. I don't have time to play to you now. But I say there are 7 ways to execute your query. Okay? I'm not going to go through all the ways because we don't have much time, but I'm going to do it very fast just to show you what I mean. So we have the same, let's empty the plan cache. We have the same query as before, this one. So one way to execute this query is this way. Okay, it's a T-SQL query without parameters. Okay, let's move on quickly. The second option to run the same query is with a dynamic patch, like this. Okay, so you have a variable for the country. At this point it's IL. I have another variable for the text itself, statement, and then I have the statement in the variable, and I concatenate the country, the value of the variable country. Okay, so in fact now this text is going to be just like the one I showed before, just like this. Okay, and this is going to be executed by the dynamic batch. So the result will be the same text, although it has different tabs and enters, different text, not exactly the same text, so it will be a different compile, but essentially it's the same query without parameters. Another way to run this query is this. It's again a dynamic batch, but this time I have a parameter inside the dynamic batch. I call it @p_country. It's an internal parameter to the batch, dynamic batch, okay? And I define this parameter here, and then I use this system stop procedure, sys sp execute SQL, to run this batch. But now I have parameters, and I can pass in the value of the parameter. Okay, so this is the first time that we see a parameterized query, dynamic batch. Let's run it. Okay, we get the same results, of course, but if we look now in the plan cache, we can see that it's a prepared statement. It's a prepared plan, meaning it has parameters. We can see here the definition of the parameters, and also if we look at the plan, we can see here that we are using a parameter and not a constant value. Okay? Nowhere in this plan you will find the value IL or any specific value. This is a template now. Okay? And we can reuse this template for different values of the country. So for example, I can now run the same batch, but only change this to FR, and I will get the French customers. And of course, if I check the plan cache, we now have a reuse. Okay? So we can use multiple countries, whatever we like, we'll get the same plan each time, which is great. We can also run this from the client application. I have a demo here to show you a .NET application, but I will skip that because I want to show you other things. Okay? It's the same thing more or less. We write code in a .NET application or any other application, we should use parameters. So for example, with ADO.NET, we can add a parameter object and add the data type, the value, the direction, whether it's input or output, just the same as we do here. Let's skip that. Another way is, to, of course, stop procedures. Okay? So I have a stop procedure here with a country parameter and the same query, of course. Now let me execute the stop procedure with IL. Okay, let's look at the cache. So now we have a proc plan. It's a different type of plan. And now let's execute it again with FR, with the French customers, and look at the plan cache again. And of course we get a reuse as well. Okay, because again, with stop procedure we have parameters. That's great. The last one, number 7, okay, is this. I call it looks like parameterized T-SQL query, because it looks like a parameter, but it's not. What happens here is I declare a local variable, okay, and then I run this. The problem here that local variables like this one and parameters like this one, they look the same. They both begin with the @ sign, but they are very, very different, and it's very confusing. It's misleading. Okay, if we look here, let's run this. Then first, oh sorry, I need the actual execution plan. First, if we look at the plan, we get a different plan now, for some reason. It's not a seek anymore, it's a scan. And the reason is that now we still have the 55 actual number of rows, but now the estimation is this. Now the optimizer is wrong. And because the optimizer thought there will be so many rows, it says, okay, I'm not going to do so many key lookups, I'm going to use a class to do the scan. And of course, it was wrong, and we have a poor plan, we have poor performance. Okay? This is one problem. The other problem is that if we look at the plan cache, you'll see that it's an ad hoc query. It's not prepared. It's not a parameter. Okay? And if we run now the same batch only with French customers, look at the plan cache again, then we have, of course, another one. Okay? We don't have a reuse. Okay, so this is really bad. The question is why? Why does it behave like that? And I will answer that in the next slide. So we need to understand parameter sniffing. Okay, for that. Parameter sniffing in SQL Server means when you have parameters like in a stop procedure, the first time you are going to execute a stop procedure, SQL Server has to generate a plan for you. Okay, because the first time we don't have a plan yet. Okay? In compile time, while generating a plan for this stop procedure, there is parameter sniffing. SQL Server can sniff the values of the parameters. It knows the values of the parameters in this first execution at compile time, and it can use these values and check statistics in order to estimate the number of rows and come up with a good estimation and a good plan. Now this is a great thing because otherwise, without parameter sniffing, the optimizer would have to guess. Because it has no idea about the parameter values, it would have to guess how many rows are going to return for Israel customers or maybe French customers. We don't know. Okay? Fortunately, we know. The optimizer knows. It's called parameter sniffing, and it happens only in the first execution. Because once we have a plan after the first execution, it puts the plan in the plan cache, and from that point, we are going to reuse the same plan again and again, regardless of the parameter values. Okay? So this is parameter sniffing. Now, local variables we declare are not parameters. They look like parameters, but they are not parameters. And we don't have parameter sniffing for local variables. So when we declare a local variable, at compile time, when SQL Server needs to generate a plan for the query, it doesn't know the value of local variables. They are considered unknown values. And for unknown values, the optimizer has all kinds of rules for how to treat them. I will show you that later. Okay? But in many, many cases, the optimizer will get it wrong. It will get poor estimations, and then will get poor execution plans and poor performance. Okay? So this is the reason why local variables are problematic. The question is parameter sniffing good or bad? On one hand, it's a good thing, like I said, because the optimizer can generate a plan based on real values, actual values, not just wild guess. On the other hand, if we have different parameter values in different executions, maybe in the second execution, some other user is going to use the same store procedure but with completely different values, which will bring completely different number of rows. But now we are stuck with the same plan that is not appropriate for that execution. Okay? So that becomes a problem. All right? Think about it. I love this example. Think about it. If you have a new job, you've just got accepted to a new job at some big factory. Okay? They put you in a big warehouse with lots of packages of all sizes and shapes and colors. And your job is to stand in that warehouse. There is a big production line with all kinds of products being produced. Okay? They tell you you should stand there. Whenever a product comes from the production line, you need to find the best matching package, the best package in the warehouse to pack that product. Okay? That's your job. With the right size, the right shape. Okay? Pretty easy. You're very excited, you go into the first day in your job, you go to the warehouse, and before you start, they tell you, oh, wait a second, we forgot. There is a very important rule. Only for the first product, you can choose whichever package you like. But once you chose a package, you must use the same package throughout the day, for all products. Sounds weird. You say, okay, that's the rule, I can live with it. Okay, so you start your day, and the first product is this, a bunch of pencils. And you search the warehouse for all kinds of packages, and you find the perfect package, more or less. Okay? Imagine that it goes in. Okay, you find the perfect package. It takes some time in the first time, but you found it. You put it in, it's great, and now you remember the rule. Okay? From that point, you can only use that package. So you grab a bunch of packages like this one, put it beside you, so the next time you have the same bunch of pencils, you're very fast. You have the package, you put it inside, so now you have good performance. Okay? But then at some point, you get this, another product. And there's a rule, right? You have to put this into that. This will take some time. Not very good performance. Maybe you do this, okay? But it will take some time, right? So this is parameter sniffing. It sounds crazy, but this is how it works. There is this strange rule. You get your plan based on the first execution, and now you're stuck with it. Okay, that's it. Let me show you a demo. Let's empty the plan cache. So now, first I want to show the statistics. Okay, DBC shows statistics on the country index. I want to show you the histogram, the distribution of countries in the table. So we can look at the histogram down below. We can see the different countries. We can see that for most countries, we have around 70 customers. Okay? But for China, for example, we have lots of customers, 30,000. For UK, we have 30,000. For US, we have 40,000 customers. Okay? So we don't have an even distribution. Of course, this is a very simple demo. Okay? It's not a real-life demonstration, but to get the idea, we have all kinds of distributions in real life. So now, let's say some customers, some users want to ask for the Israeli customers, some users want to ask for the US, the American customers, okay? But they have different cardinality, different number of customers, of course. So I'm going to execute now the store procedure we did before with Israeli customers first. Now it's the first time because I just emptied the plain cache, okay? So we get a compilation, we get an index seek, we get an estimation of 55, which is the actual number, which is great because we have parameter sniffing. This 55 comes from statistics based on the IL value, Israeli customers. But now some other users tries to execute this store procedure with US. Okay? And this is a problem because we get the same plan, because it's in cache. We use the same plan, but now, if we look here, the estimated number of rows is still 55. Not because the optimizer was wrong estimating how many Americans are there, because this is what it has in the plan cache. It must reuse the same plan. But the actual number of rows is this, in this case is this. It's completely different. Okay? And for this number of rows, a scan would be better. But we are stuck with this plan, which is very, very wrong. Okay? Not good. I can show you, if we look at the select operator and click properties, we have here the parameter list. Okay? So you can see that we have the country parameter and we have the compiled value is IL. This is the value used in the first execution to compile, to generate the query plan. And the runtime value right now is US. Okay? So this can give you a hint why there is a problem here. Okay? And of course, it's the problem. How do we solve this problem? What do you think? Any ideas? Yes.
We can recompile every time.
Great. We can recompile. Thank you very much. I have here some candies for people who answer my questions. Thank you. So we can recompile every time. We'll show you that in a second in demo. Okay, great. That's one answer. Anything else? I have another one. What else can we do? No? Okay, I'll take it. So, first of all, we can run this. sys-sp recompile. Sys-sp recompile marks this store procedure as invalid. Okay? As I explained before, sometimes a plan becomes invalid. We can decide which plan becomes invalid. We can say, I want this plan to become invalid, so the next time someone tries to execute it, they will get a new plan. Okay? So I do this. Now think about it, this is just a matter of luck again. It's like a casino. Okay? You get a free roll of the dice. Try again, maybe now you have luck. Okay? Maybe it works, maybe not. Because I don't control the next user is going to execute the store procedure. I don't know with which parameter values they will execute the store procedure. So now, let's say that the next user is going to use US, giving the American customers. Okay? So now we get a good plan for the US customers. We get a scan. This is great. But of course now, we have the problem in the opposite direction. Because the next user who wants the Israeli customers is going to be stuck with the scan, which is not the right plan. Okay? We have an estimate number of rows like this, and the actual now is this. So it's the opposite problem. Okay? So for some cases, this can be a good solution, at least for the short term. Okay? Because if now we have production problem, we have a real problem, we need to solve it as fast as possible, first thing we can do is do this. And maybe it will help. And then we can think what happened and how can we solve it and so on. Okay? So it's a good thing to start with. We have nothing to lose. Okay? But a better option, like the gentleman there said, we can recompile each time. So we can add to the store procedure itself, we can add with recompile. Okay? This means that whenever somebody executes a stop procedure, it will be recompiled each time, each and every execution. Okay? And each time we're going to have parameter sniffing. Okay? We're going to look at the specific values in that execution, and we'll get the best plan for that execution, which is great. Okay? SQL Server will not even put the plan in the plan cache because there's no point. It's going to be replaced each time. Okay? So this is also good. What is the problem with this solution? There is a problem with it. Sorry? CPU, exactly. Okay, so it's great because we'll get the best plan for each and every execution. Really, it's great. But if we're going to execute this stop procedure many, many times, we're going to have lots of compilations and lots of CPU overhead. Lots of CPU. So if this is a stop procedure that runs 100 times per second, say goodbye to your server. It's going to be down on its knees. Okay? On the other hand, maybe this is a data warehouse, and this stop procedure is some report that people run every hour. That's fine, no problem. No problem at all. Okay, so you need to consider it. What is the scenario in your case? Let's see in action. We recompile. And now, when I execute with IL, I get index-seq. When someone else executes with US, they will get clustered in the scan. So every execution gets the best plan. Wonderful. But again, be careful. If it's running lots of times, it's going to be a problem for your CPU. A better solution is to use option recompile. Instead of with recompile at the stop procedure level, we can use option recompile at the statement level. There are two important differences between with recompile and option recompile. One, with recompile, as we've seen before, happens at the stop procedure level. So if the stop procedure has 20 statements, all of them will be recompiled. The entire procedure will be recompiled each time. Okay? Option recompile happens at the statement level. So maybe out of the 20 statements, only statement number 8 is the problem. There's no need to recompile everything every time. Okay? So I can specify option recompile only for the 8th statement. And only that statement will be recompiled. So I will save lots of CPU. This is one difference. The second difference between with recompile and option recompile is very important. With recompile happens at compile time. Okay, so every time a user tries to execute, SQL Server first needs to generate a plan for the entire procedure. This is compile time. It will generate the plan, and only then it will start executing it. Okay? While option recompile happens at runtime. There's a big difference. So the stop procedure starts executing. It executes statement 1, 2, 3, 4, 5, 6. It gets to number 7. Sorry, we said 8, right? It gets to number 8. Okay, it stops and says, okay, I will recompile this statement, will execute it, and continue to statement 9, and so on. So this recompile happens at runtime. And it's a very big difference because at runtime, SQL Server knows lots of things that it doesn't know at compile time. For example, we talked about local variables.